So hi everyone, I'm Eva Atkinson, and yeah, I'll talk about CloudFormation. Has anyone used AWS before? Yes, a few people. Cool. So yeah, I'm Stephen Atkinson. I work at Dutrix as a software engineer. There's some of my handles, so you can see my repos. Can't really see much on GitLab because most of that stuff's private. Before GitHub did private repos. I started out as an apprentice at Hitachi Automotive Systems. That was about 8 years ago. So yeah, it's been a long journey. And now, yeah, I'm at Dutrix doing a whole load of different things. At Dutrix, we work with a load of different people like Heathrow, P&O Ferries. We do like design sprints and help people with digital products, and yeah, do a lot of cool stuff in like different languages like Electron, JavaScript, .NET, some PHP and Python. Yep. So, what is CloudFormation? CloudFormation is a way to provision your AWS resources using a template. So you can use YAML or JSON to define what resources you want to spin up, and you can store it in an S3 bucket, or you can just, with the interface, upload it locally and push it and create all your stacks, which contain like your S3 buckets, your Lambda functions, your DynamoDB tables, a whole manner of things. And with those things, you can spin them up however many times you want in different regions, on different accounts. It's pretty powerful. So yeah, we've got CloudFormation, and you can spin up a whole array of things. So yeah, why should you use CloudFormation? So as I say, CloudFormation, it's easy to spin up like a ton of different resources. It enables you to like document what you're doing as well. So you can store it in source control. You can like share it around, so you can pass it to another person and they can spin up an environment in their own account. And you can deploy it in just a few clicks as well. You can deploy it to different regions. And yeah, the best thing is that when you finish like developing your application, you can just clear your stack and it clears away all your resources, so you don't have to manually go in and go, oh, I created this S3 bucket for something, let's delete that, and because that can be a bit time consuming. So yeah, so you know, you get to deploy a whole ton of resources. You don't have to deal with going through the services menu and going, where's Dynamo, where's IAM, because you know that menu just gets bigger and bigger every single month. And it feels good when you can just spin up an environment, you can just see the list of resources spinning up, and it just feels good. Because I'm sure you've been in a project before where you're like, okay, I need you to work on this. You go, okay, well, how do I get it running? What do I need? But with CloudFormation, you just have everything there. So how do you write CloudFormation templates? So the way I've done it, I'd use YAML templates. So you can create your VPCs by just declaring this block, which says, okay, I want to create a VPC. I want to give it this CIDR block. And there's like a ton of properties you can put on there. And there's like some handy functions like sub where you can put in variables. So when I create this VPC, it also includes the stack name as a prefix on it. With lambdas, you can even put code in there as well. And you can also, with the getAt function, you can link roles created in a CloudFormation template to that Lambda as well. So you can give it permissions to do certain things. So you want to build an API. That's basically what this talk is about. We're creating an API. So you know, the hardest part is coming up with an idea. So I've had a week to come up with an idea, and I have come up with a voting API. Very, very, very simple.
For the second referendum.
I missed a trick there. Missed a trick. So for this API, we're going to get a list of questions. So that's going to be its own route. And we're going to allow users to vote on an answer. Not Brexit, right? So what we're going to need? We're going to need a database somewhere to store our questions. We're going to need an API gateway, so we got like routes to hit so we can get responses back. We're going to need some functions to attach to that API gateway so it knows what to do when you hit that route. And we also need some IAM rules to allow our functions to talk to whatever they need to get data. So we've got a list of tasks. We know what we need to provision. But before we get down to it, it's probably best that we kind of define what our API is going to look like. So for that, I use Swagger. Has anyone used Swagger before? It's a pretty cool tool. That's all YAML based as well. So on our header of our Swagger template, we've got like a few different bits of information, like the title of it, the description, link to some external docs, what scheme you're going to use. And there we have a list of objects we can use in our routes as well. So like if we return 2 or 4, we'll just return an empty object. For our list of questions, we're going to return an object with a data array that's full of question items. And this is how we define routes. We just give it a path, give it the method that it uses. So you do a get questions, and then it returns a 200 response with that object that we saw in the previous slide. And with post, we've got a route that's got a thing in curly brackets. So that's a path parameter which we can also pass into the declaration, but it also accepts a body object which has an answer in it, so we know what we're voting for. So when you're using the Swagger editor, it'll spit out some documentation that looks like this. So if you're developing an API for a client, you can just give them a link to some Swagger docs and it'll just generate this fancy looking document so they can consume your API. So why we're talking about Swagger is because you can integrate your Swagger documentation in a CloudFormation template. So you've generated your Swagger documentation, you generate your REST API resource, and in the body property, you can just drag in your Swagger template, which is pretty nice. So you've got client documentation and stuff you can use yourself. But there's one more thing we need to do before it can actually work with the Swagger templates. We need to define this new X Amazon API Gateway integration property. And that allows API Gateway to know what to do when it hits that route. So when we hit that route, it knows to go to the get questions lambda. And with every lambda, you need to send it as a post as well. That's something I learned from doing my first API. And on the post one as well, we've got our URI to our post vote lambda as well. Yeah, and that returns our 204 because we don't need a response back from that. And when we're attaching lambdas to our API gateway, we also need to attach some permissions to it so the API gateway can actually execute those lambdas. And this is what these 2 bits of template do as well. And that depends on just means it's waiting for the API deployment resource to finish building before it actually puts the permissions on. Because if you don't do that, then it just, yeah, doesn't work. And we also have a few roles as well. So in order to get our API gateway to log to CloudWatch, we also need to attach a logging role to it as well. So that when you're like making a request to your API gateway, you can go into the logs and see exactly what happened. It's because it's pretty useful when you're not getting the responses you expect back. So let's take a peek at our root lambdas. So this is a simple, I say simple lambda. It's pretty simple, and it just hooks into DynamoDB and just gets a list of questions out of that. And it's got our questions role attached to it, which allows us to, it gives us permission to scan the DynamoDB table. And as you see, we've got variables at the bottom, which is referencing the question table resource that we create. So we can inject that into the Lambda so it knows when it's scanning DynamoDB, it knows what table to hit, which is pretty powerful. And for our post-vote Lambda, it pretty much does the same thing, but it just does a update item call instead. I need it as a separate permission for that. And in our CloudFormation template, we can also seed the database as well, so we don't have to manually create a route which just posts some random data in there. So I've created another function which is called populate questions lambda, and that just creates a batch write with a bunch of questions in there. There's one there, but I put 2 in there. And that's got another role attached to it. And to execute that lambda, we need to create a custom CloudFormation resource. And that basically, when it runs through the CloudFormation template, it'll just call that lambda and just populate the table. So we've got our API gateway, REST API resource, got our lambdas, but there's a few more resources we need to actually deploy the API. So one of them is the API deployment one, which just takes in the API gateway ID. But the main one is the API stage, and that allows you to get a REST URL which you can hit to actually test your API. I don't know why it's not in deployment for the stage. And you can also enable logging on that, which is why we need that other logging role. So I do have, I've not done demos, I've just done videos, just to be safe. There we go. This is the CloudFormation window, so we can create a new stack. We select our CloudFormation template. It stores it in S3. We give it a name. Let's call it My Voting API. If you've got like a parameterized CloudFormation template, parameters will come in there as well. When you assign tags, those tags get applied to every single resource that gets created, so you can keep track of all your resources. You can attach policies to your stack so things don't accidentally get deleted. Like if you spin up a database and then you delete the stack, you don't really want that database to get deleted. There's some rollback stuff you can do, and you can have notifications when your stack's completed. And you can also have termination protection. So if you've got like a production stack, you don't want to just be able to press delete and it just goes away. So there's a few safety measures in there. And that's just a summary of all the stuff that we put in. And because we're creating roles, it's come up with that checkbox to say, okay, we're creating roles as well. And this doesn't auto-refresh. So you just have to keep pressing refresh all the time. It's one feature they should probably put in. After a while, we'll see all the resources start spinning up, saying they've been created. It does take a while, but it's still quicker than doing it all manually.
Is that because you can walk away and make coffee?
Yeah, that's the perfect time. So
The question you put in is, what's your favourite cloud provider? So what's the answer? I'm guessing AWS.
Probably GCP, right? Or OpenShift. So yeah, we're seeing all those resources getting created. And when we create the stack, you can also assign a permission that runs the stack as well. But if you don't do that, you just use the permissions on your user account. So say you've got a user account that doesn't allow you to create DynamoDB tables, then it'll just fail to create the stack. And it'll just roll back and just not create anything. So we've got all our resources there. And it's completed in like 2 minutes, which is pretty cool. So if we look now, we can see a list of resources. And if we go to IAM and go into roles, we should see our list of roles that have been created. So with the roles, it just prefixes it with the name of the stack. So create a policy to allow reading from DynamoDB when we've got our scan permission. When we populate questions, we've got our batch write item permission in there. It also has like the name of the table that you can write to as well. And in our post vote lambda, we can update an item as well. And that's attached a managed policy to that role. And that allows us to log from API Gateway. Now we can have a look at lambdas. So we go into lambda, we can see a list of lambdas that got created. So see we've got all our code in there. We've got our tag that we set before. We've got our role that's attached as well. All stuff that could be done manually, but why do it manually when you can just template it all out? We've got our post vote as well. Again, tagged, environment variable set in with the table name, and our role attached. And same with the get questions lambda. With your table name and your tags. And if we go to DynamoDB, if we go into tables, we'll see that we've created our questions table as well. And we'll see that our populate lambda have been triggered. Encryption's enabled on that. Yeah, so we've got our 2 items that we put in, and that was triggered by that custom CloudFormation resource. And the main bit is the API gateway, which is the thing that just puts it all together. So we've got our voting API with our list of routes, and we can go in there and see everything's all set up properly. So didn't do any settings on that. There we're attached to our get questions lambda in our EUS2 region, and our 200 status uses our get question success model and returns it as JSON. We've got our post votes as well, and on this one in request path, because we've got a parameterized URL, it puts that in there so we can access it in our Lambda function. And also because we accept a request body as well, it puts that in there as well and gives it a funky name. And again, attached to our Lambda, attached to our region. and we get a 204 response back with an empty model. That's a list of our models that we created. So the ones with the names are the ones that were created in the template. And it links all the models on its own. And that model 87 is the one that got created in the Swagger template for the request. In the template as well, we'll also define some gateway responses as well, because you can customize those. So instead of getting like some weird AWS kind of error, you can create your own. Because sometimes you want to abstract away what cloud provider you're using, or if you're using multiple ones, you want the messages to be the same. And for our stage, that's where we can get our URL. So if we hit that, and then on there, I'm typing the questions URL. So when we get that, we get our list of questions. And that's all getting pulled from DynamoDB. And we also have, because we created our logging roles as well, by default, because we've attached the execute lambda role to our lambdas, it just logs on its own anyway. So yeah, there's a few like console.logs in that lambda function which just output messages to CloudWatch. And that just says it's finished because there's no console logs in there. Because that's the way we debug, we just console log everywhere we can. Yep. If you're doing PHP, you just echo everywhere. It's just the same. Yes, that's an error I got before when I was debugging. And when you clear up an environment, it doesn't get rid of the logs, so I am just going through each one of these and figuring out which one it was. Yeah, that one didn't get deleted. So there are still a few manual tasks you need to do unless you want to just leave those logs in there. So when I hit that URL, it just spun up all that stuff, so you could see if it transformed the body, because you can transform responses and requests to make it fit what body you want to get sent into the Lambda. So what if we made a mistake when we first deployed our CloudFormation template? Would we have to delete the stack and then recreate it? Well, turns out you don't need to. You can just replace the current template with a new one with the updates, and it'll just do a diff on them, and then it'll update the resources that need updating. So if you got one of your, I don't know, your response body is wrong, or your Lambda function needs changing, you can just update it in the template, redeploy, and it only updates that bit, which is pretty cool. So on there, we'll see what's changed. So we changed the get questions Lambda and the API gateway. Sometimes if things relate to each other, it'll have to recreate multiple things. But if you're just creating a Lambda, then it'll just do it by itself. And updates are pretty quick, because it doesn't have to recreate a ton of stuff. After a while, say in like 10 seconds. So I updated the model because it was wrong before, and now it's magically changed. So when I'm like testing APIs, I tend to use Postman. Does anyone use Postman? Postman's pretty cool. So I've got my URL from the API gateway stage. Hit the root. Boom. Got my response back. So I can use the ID to send in my post request to the votes. And that'll trigger my post vote Lambda. So you get a 204 response, which means it's worked. And then you'll see that the vote count's changed. You can hit it as many times as you want as well. Yeah. Very one-sided, but So we can also answer another question as well with a different ID. So we can just keep upvoting.net. Keep going, keep going. Then we see that's changed as well. And we'll see that whenever we hit that, we get the logs as well. So if we've got like transformations, it'll say before transformation, do some transformation, then it'll give you another thing that says after I've transformed it, this is how the request body looks. And in our Dynamo database, we've got our updated items in there with the new vote count. There is a new feature on CloudFormation that has recently come out, and that is drift detection. So I'm sure you've had it where you're kind of like debugging what's going on in your environment. You're like, oh, let's tweak this setting and see if that does anything. With drift detection, if you've deployed your entire environment with a CloudFormation template, and you update a value on one of those deployed resources, it will tell you. It won't do anything, but it'll just tell you. So we've got that drift status thing on there, so you have to actually manually trigger it. So you need to detect the drift. It doesn't do it straight away. If you refresh enough times, eventually it gives you a response. So we're in sync. We're still in sync. So if I go and change something now, so if I change like the timeout setting on this Lambda function, because oh no, it's timing out, I need to reduce it. Don't increase it, there we go. So I've changed it, it's not the same as the template anymore. Go back into, oh, I've drifted. It's not the same anymore. Although it still says it's fine, but for some reason the Dynamo DB table's changed and I'm not even touched that. Even though encryption is enabled, so yeah, okay. So just detect drift again. There we go. It's saying our Lambda function's changed. So we can click on it and say, okay, how's it drifted? And it'll say that we've changed our timeout value, which is pretty sweet.
Does it also pick up changes to your Lambda code as well?
I did look at that, but it didn't seem to. Because you tend to make changes to code, don't you? Yeah. So it'd be nice if it could actually do that. But it's a relatively new feature, which contains a bug. So
it'd be a handy way to see if your Lambda functions have been compromised.
Yeah, but normally you deploy Lambda functions in like zip files or something, don't you? Rather than in your actual templates.
You can still use the AWS CLI to update your Lambda functions directly.
You can.
Yeah.
You can.
How to do that.
Yeah, so we've just seen a bug with our DynamoDB table, and it's a relatively newly reported bug as well, because that feature isn't really that old. But yeah, I was really confused. Did I change that time? No, I didn't. So, what did we create? How many things did we create? So we created a DynamoDB table, created 3 Lambda functions, created 2 Lambda permissions just for the API gateway, created 4 roles. CloudFormation is pretty awesome. I mean, you could still do stuff manually if you really wanted to, if you really wanted to kill some time, but it's a lot better and a lot easier for everyone in your team if you do it in CloudFormation, because you can document what your environment looks like. So you don't have to go around and say, oh, have you installed this? Have you provisioned that? It's just all documented. And if you are unhappy with a region for whatever reason, you can just spin it up somewhere else. Like, oh, we don't want it deployed in Ireland. Let's just spin it up in London instead. You can just go, okay, boom, done. And if you want to update your resources, just update the template, push it out, easy. And therefore, with Swagger, you can just extract your API spec, put it into a Swagger editor, and give it to your client so they can use your API. And you can detect drift now, which is pretty cool. So yeah, that's how to deploy an API gateway in CloudFormation. Has anybody got any questions?
Gee, well, I was going to clap.